Thank you all for staying to the very end. My name is Ethan, and unlike the wonderful speakers we have had so far today, I do not have rare disease. But I'm here to talk about myotubular myopathy, which is a rare genetic disease that runs in my family. And thankfully I don't have it, or if I did, I would not be alive today at age 20. You can kind of see a little bit. That's me on the left, back when I was still cute, a long time ago. And in the middle is my cousin Patrick. Patrick was born with myotubular myopathy. He was born 2 months prematurely, and he was so small he could fit in the palm of your hand. Perfect. And for the first 3 months of his life, they didn't know what he had. He was super small, he had a bunch of problems, he was on a respirator, and it took 3 months of tests and shots in the dark for them to do a muscle biopsy and discover that he had myotubular myopathy. Here's another picture of Patrick, he was a little bit older, with meeting his younger sister, Mama. And so a little bit about the disease. Myotubular myopathy is the best way to describe it. It's like severe muscular dystrophy. So there's muscle problems throughout the entire body, but also other problems. It's X-linked recessive, which means that the mothers carry it, and if a mother is a carrier, her son has a 50% chance of inheriting it. So my grandmother was a carrier, and 50% chance, thankfully, my father was born with that disease. However, my 2 aunts inherited the trait, and so they are both carriers. And one of my aunts had Patrick, my cousin, who was affected by the disease. Myotubular myopathy is a genetic disorder, and so the mutation results in a defective myotubularin protein. It's a spectrum disorder, so depending on where in the gene the mutation is and how serious the mutation is, that will decide how serious the disease is. There are about 500 people in the United States who have myotubular myopathy currently. Most of these families are enrolled in a large-scale research study that's going on throughout the entire world. And I've talked to the researchers, and they say that our family has had more reported cases than any other family in the entire world. And also, the mutation is a large-scale deletion for our family. And as far as the spectrum goes, the young boys in our family are about to have the most serious form of the disease you can have and still be born. So there are several symptoms. The most prevalent symptoms are muscle problems, such as hypotonia, so a lack of muscle tone. You can kind of see in the picture, his arm was kind of floppy, kind of like a baby's arm. That's the most prevalent symptom. But also because they have very weak muscles, they're on a respirator because they can't breathe on their own. One of the problems is that the defective protein myotubularin is present in every cell of the body. And so there are problems beyond just the muscles. So there's ion imbalances all over the body, including in the brain. They have liver problems. They can't digest some proteins, leading to amino acid imbalances. And because they're constantly undergoing different operations to combat these symptoms, they have constant infections. There are neurological problems. And so while these boys are cognitively normal, and in most cases several grade levels ahead of an average child, they are perceived by most people as being cognitively impaired because they can't speak on their own because they're on a ventilator. And in addition, they actually do have neurological problems. Many of the boys have seizures. And that's actually what leads to the passing away of many of these boys is that they have chronic seizures. In addition to the direct physical problems, there's also lots of suffering involved. Some of the medications that these boys are on for their different problems lead to intense sensations of itching and pain, but because they can't speak, they can't tell their family or providers that they're having these problems. And so Patrick, for one long stretch, was having itching sensations off the itch scale but he couldn't tell anyone. So it was in excruciating pain, but couldn't express that. And so as you can imagine, there's a fairly poor quality of life associated with the disease. Most of the boys are bedridden, and most will never walk or talk. After fighting valiantly for 8 years, Patrick passed away about 10 years ago. As I mentioned before, one of the biggest problems is seizures, and by the end he was having upwards of 100 seizures a day, and that amount of overstimulation in your brain literally just turns into mush. And by the end there was nothing there. But there is a happy side to the story. Having a cousin like Patrick changed my life and convinced me that I want to be a doctor and that I want to go into research. And it taught our family a lot about dealing with troubling times and stuff like that. And also, being in the United States, it really is a lovely country. And we realize how lucky we are because our family still lives in Canada, who also have the disease. When the boys are born there, even today, the boys are born and they're taken away and they're allowed to die because their technology is behind ours and it also costs too much. So they let the young boys die. So. A happier part of the story is that I got really interested in researching the disease from being around Patrick. And so, as I mentioned before, our family is involved in an international research study for all the most of the families in the world who have the disease. And so, through my aunt, I contacted the professor at Harvard Medical School who runs the lab, one of 3 labs in the world researching the disease. And he said he'd be happy to take me. So this past summer, I get to live in Boston and study a disease that has directly affected my family. And so to study the disease, it's hard to study diseases in humans because of the ethics involved and the cost to directly study humans. And so we employ animal models to study the disease. And as you can imagine, to engineer mice, there's a lot of trial and error involved, and so it costs millions of dollars to create mouse line with the disease. And so luckily we were able to create a zebrafish model. And the reason we're able to do that is because the genes for mussels are so important. They've been conserved from zebrafish all the way through humans, so they're nearly the same. And so we designed a system that uses a morpholino. And what a morpholino does, you inject it into the single-celled zebrafish eggs, and it knocks down the gene of interest, in this case Myotubular. So you create a fish with artificial Myotubular Myopathy. What's nice about zebrafish is that you can grow thousands of zebrafish every day. It's incredibly efficient, and also they grow from a single-cell organism to a fully usable research model in 5 days, which is really incredible. And so my project was, previous researchers have found that when they create a zebrafish with Myotubular myopathy, there's microscopic problems with the muscles. They have tubular aggregates, which are basically like a buildup of membrane around the muscle fibers, which then inhibits function. And so my project was to figure out where the aggregates come from. And I'm happy to say after 4 months of work, which is a surprisingly short amount of time, we had good results. And so on your left, there's a wild-type fish, a totally normal fish. You can see it's got a nice straight spine. In addition, the picture on the bottom left, it's called viridescence, which is basically making the fish glow. So we use flame polarized light, and in a normal fish, all of the muscle fibers are parallel to each other, so the fish will literally glow under polarized light. In the mutant fish, you can see the stereotypical bent spine because of the malformation of the muscles, and also you can see the reduced viridescence, showing that the muscle fibers, instead of being parallel, are all over the place, all messed up. And so here, basically my results, it's kind of a cool picture, I thought. This is, so we take zebrafish with the disease, section them, and then look at their saliva under a microscope after we stain them for various markers. And I'm happy to say we discovered that the aggregates I mentioned before result from two subcellular organelles, mitochondria and a sarcoplasmic reticulum. So we had good results, which has implication for the disease in humans, which is very promising, and I was very happy to do that. The next thing I want to talk about briefly is the research process, which Dr. Graywall talked about. I think that there's a misconception with the public on how research on disease works. It's very difficult to study a human disease. First, you have to find scientists and researchers who are interested in the project. And then you have to learn all about it, develop hypotheses, and then write a grant, which is a long and tedious process. And the reason you write a grant is to get money, because without money you can't study anything. And then once you get a grant, you can't just experiment with humans, because the ethics involved. You can't try different drugs on humans right off the bat. So you have to run experiments with lower vertebrates, like zebrafish. And then if they work, we go on to mice, and then primates, and then finally to humans. And then there are several state-of-the-art drug trials in the hope that eventually you get FDA approval. Like you mentioned, less than 2% of studies will result in a viable drug. This takes a lot of time, a lot of effort, and a lot of money. And it's extremely difficult to get people to study diseases that affect 100, 1,000, even a few dozen people. Because it's so rare, they don't see the impact. And also, if you're talking about a pharmaceutical company, the profit isn't there. Which is where I think events like this come in. Through raising awareness about rare diseases, that can lead to fundraising, and fundraising leads to treatments and cures, which is what we all desire. So, thank you to Sophie, Maritza, Divya, and everyone else on the Rare Disease Committee for all their hard work. It truly means a lot to those of us affected by rare diseases, and to know that someone's looking out for us and trying to help us. So, thank you.